Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 5, Section 6, Lowest Common Multiple, or Least Common Multiple, LCM. If you are trying to find the lowest or the least common multiple of two numbers, first of all, you want to understand what a multiple is. If a multiple of two numbers is a number that they both divide into. A multiple is always going to be bigger than the two numbers, or in some cases, it is going to be one of the two numbers. It's going to be the biggest of one of the two numbers. So, for example, the lowest common multiple of 4 and 12 would be 12, because both 4 and 12 can multiply into 12. So, the lowest common multiple. There is actually a shortcut for finding it. You don't have to play the guess and check method. You don't have to list out all the factors, all the multiples of the two numbers until you find it. You can actually use the prime factorization of two numbers to find the LCM. And so, how do you find the prime factorization? If I were to take two numbers such as 12 and let's go with 7. Okay. If I were to take these two numbers and I wanted to find their LCM, I would find their prime factorization. So you're going to use a factor tree. Most of us learned how to make a factor tree in elementary school. To start, you ask yourself, what are two numbers I know that multiply to get me an answer of 12? I know 6 times 2 is 12. And what I'm going to do is I'm going to continue breaking down all of the numbers until I am left with just prime numbers. Now, I can break down the number 2 into 2 times 1, but 2 is a prime number. So we can't really break down 2 any further without causing a repeat. For example, if I broke down 2, it would have to be 2 times 1, because the only factors of 2 are 2 and 1. And then you're left with another 2, at which point you would do 2 and 1 again, and this will just repeat forever. So when you get to a prime number, such as 2, where the only factors are itself and 1, you stop. And what I like to do is I like to circle it. That way I know that branch has ended. So with the 6, we can break it down further. 3 and 2. 3 and 2 are both prime numbers, so these branches have also ended, and you can see all of my branches have ended. I'm actually going to change this number here from 7, just to make this problem a little more interesting. I'm going to change it to, let's go with 12 and 28. I know that 7 and 4 go into 28. And I know that 4 can be broken down to 2 times 2. 7 is a prime number, that branch is ended. Both of the 2's are also prime numbers. Those branches have also ended. So at this point, the prime factorization of 28 is 7 times 2 squared. And I say 2 squared because I have two 2's. The prime factorization, what prime factorization of a number is it's the group of prime numbers that we multiply together to make that number. Prime numbers are kind of cool because you can use only prime numbers to make any number that exists. So using just prime numbers, I can make every number in existence. And so what the prime factorization is it is the group of prime numbers that we multiply together to get the number at the top. So 7 times 2 is 14, times 2 is 28. 3 times 2 is 6, times 2 is 12. The prime factorization of 12 is 3 times 2 squared. I have two 2's being multiplied together here, so that's the same as saying 2 squared. 2 squared means you're multiplying two 2's together. It's just a simpler way to write it, to condense the prime factorization so it's not really long. Because when you get into some of the bigger numbers, your prime factorizations, if you don't use exponents, can be really long and take up a lot of room. So step one, to finding LCM of two numbers is to find the prime factorization of those two numbers. Step two is going to be to find out all of the individual factors. Okay? So 7 is a factor of either 28 or 12. 3 is a factor of 28 or 12. And 2 is a factor of 28 or 12. So I have 3 factors of 28 and 12 combined total. What I want to do at this point is I want to multiply these 3 factors together the maximum number of times that they appear in either 28's prime factorization or 12's. 7 only appears a maximum of once, so I'm going to leave it as 7. 3 only appears a maximum of once, so I'm going to leave it as 3. And 2 actually appears twice in one of the prime factorizations. It actually appears twice in both of them, so I'm actually going to multiply 2 squared. Now, an easier way to figure this out is if you do write out the exponents, you'll end up with 2 times 2 here, and 2 times 2 there. A quicker way of figuring this out, instead of having to take a look at each individual number, is you find the numbers that they have in common. You can see that they share 2 sets of 2. Here and here. And all you're going to do is cross out the bottom row, or the top row, your choice, but one of the rows of 2 that they have in common, and then you multiply what you have left over. So I'm going to do 7 times 2 times 2 times 3, and that will be my LCM. So 7 times 2 is 14, times 2 is 28, times 3 puts us up to 56, 76, 84. And so the LCM of 28 and 12 is 84. Okay. So I'm going to do one more example just to make sure we have this, because I know this might not necessarily make the most sense the first time around. So again, first step is to find the prime factorization. So this time I'm going to use the numbers 108 and 240. So if I break down 108 into its prime factorization, I'll do 2 times 54, 2 times 27, and I'll do 9 times 3, and 3 times 3. So what you're going to notice, I've got a branch that ends here, 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 and here. So we actually have a few more numbers in our prime factorization this time. With 240, we break that down into 10 times 24, 5 times 2. These are both prime numbers already. I'm going to break down the 24 into 12 times 2. And I'm going to break down the 12 into 3 times 4. And I'm going to break down the 4 into 2 times 2. So at this point, I have a branch that ends here, 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 and here. So we have two numbers that have bigger prime factorizations than the previous two we used. So let's take a look at 108. We have 2 times 2 times 3 times 3 times 3. Prime factorization of 240, we have 5 times 2 times 2 times 2 times 2 times 3. Let's just make sure I have that correct. We have 1, 2, 3, 4 2's. We have 1, 3 and 1, 5. Okay, so first step to finding the LCM of these two numbers is to find their prime factorizations. I've written their prime factorizations out. I'm just going to make them a little bit bigger so it's easier to see them. For 108 we have 2 times 2 times 3 times 3 times 3. For 240 we have 5 times 2 times 2 times 2 times 2 times 3. So what we do at this point is we find the pairs of numbers they have in common. So we can see that there's a pair of 2's in common here, a pair of 2's in common here, a pair of 3's in common here, and that's all I have in common. And at this point, we need to cross off either the top or the bottom row of those pairs that they share. I'm going to cross off there and there. So we're missing now 2 2's and a 3. At this point, I take the rest of the numbers, multiply them all together, and that will be my LCM. So, I'm going to do 2 times 2 is 4, times 3 is 12, times 3 is 36, times 3 is 108. 108 times 5 would be 540. 540 times 2 is 1080. 1080 times 2 is 2160. So the LCM of these two numbers is 2160. Okay, that's a big LCM, but some numbers, that's the way it works. Their LCM doesn't necessarily have to be close to them. So that's really about it on LCM. Tune in to the next video where we'll talk about the LCM of monomials. So we're going to add some variables into the mix. And we'll also talk about briefly in the beginning of the next video about the lowest common denominator and how do you find that using the LCM.